Hello everybody, it's Miss Fincham. Today we are continuing Unit 2 by covering topic 1.7, which is the hydrologic or water cycle. Just like in all of our other biogeochemical cycles we've covered, we'll be looking at how water moves between sources and sinks. Our objective for the water cycle is to be able to explain the sinks and the reservoir interactions in the cycle. Our practice FRQ will use the scientific skill of explaining differences between environmental concepts using a visual model. The hydrologic cycle is the movement of water in different states between different sources and reservoirs. In this cycle, we like to focus on, first of all, what state of matter that water is traveling in, whether that's solid, liquid, or gas. But then also, where is the water moving? So what reservoir is it leaving and what reservoir is it entering? For example, we could look at precipitation, which we probably already know as rain, and that is going to be water moving from a gas in the atmosphere as it condenses together into clouds and then eventually falls back down to earth as a liquid. The reservoir it's leaving is the atmosphere, and the reservoir it's entering is a little bit trickier. It's going to be hitting Earth's surface, and it could run off into a body of water. Then it would be entering what we call a surface water or body of water, or it could infiltrate into the ground and it could become groundwater. Those are the two reservoirs water might be moving to. It is also really important to know that the hydrologic cycle is driven by energy from the sun. This is kind of a tricky concept, but think about the body of water that is exposed to sunlight. As the sun hits that body of water, that's going to cause the water at the surface to warm and eventually turn into a gas and evaporate. The largest reservoir of water on Earth is the ocean. That's important to know, but some smaller reservoirs are the polar ice caps, glaciers, and ice caps found on mountains, as well as groundwater. These are very important because they're fresh water sources. Humans can't use salt water from the ocean for things like agriculture or drinking, but we can use these freshwater sources. Even though they're a lot smaller, it's really important that we remember that these are our key freshwater sources. Evaporation and evapotranspiration are the two key sources or processes that move water from a liquid form on Earth into a gas form in the atmosphere. Sometimes we call this the vaporization of water. Excuse me, because it's liquid water transforming into a vapor or gas that enters the atmosphere. Transpiration is the process where plants are going to draw water up from the ground via the roots and up into their stem and their leaves and other places in the plant that needs water. They do this with a really neat trick, and they're going to use these little pores in their leaves called stomata. The stomata open up. If we look at the diagram here, we can see these pores basically are in the leaf. They're going to open, and water vapor is going to evaporate due to the sun's energy. What that does is creates a low pressure system where the leaf has a lower water pressure than the roots, and that's going to draw water up from the roots to replace the water in the leaf that evaporated. In the diagram here, we can see that the water that's in the ground will be drawn up the roots, up the stem, into the leaves because we have low water pressure in the leaves. They open their stomata and allow the sun's energy to evaporate the water, causing transpiration. As a summary, transpiration is the process of a plant drawing water up from the ground via its roots by allowing some of the water in its leaves to evaporate. We also have a concept called evapotranspiration. Evapotranspiration is just a way to add up the total amount of water leaving an ecosystem by both transpiration and evaporation. If we look at the diagram, the water that evaporates from the soil or from bodies of water combined with the water that leaves plant stomata via transpiration would be considered evapotranspiration. It is really important to remember that both processes are driven by the sun. When the sun's rays strike the soil, some of the moisture in that soil will be heated up and it will evaporate as a gas into the atmosphere. And the same thing with the leaf. When the leaf has its leaves warmed by the sun and it opens its stomata, some of the liquid water in that leaf will evaporate as a gas. Again, that's how the leaf is going to actually draw more water up from the roots. Finally, we'll talk about runoff and infiltration. When precipitation falls to Earth's surface, it can do one of two things. It can either flow across the surface until it reaches the body of water as runoff, or it can slowly trickle into underground water stores called aquifers, and we call that process infiltration. We can look at the diagram here and we can see that if the water hits the surface and just flows into a body of water, we call that surface runoff. If it hits the ground and it's able to soak into the ground and eventually reach an aquifer or an underground water storage, we call that infiltration. These two processes are very important because they contribute water to very important freshwater reservoirs. Runoff will recharge surface bodies of water, which are important drinking sources for humans and important sources for agriculture. But they also recharge groundwater, which can be especially important water sources in dry areas where humans have to use a well to draw water from the ground. Remember that precipitation is going to recharge groundwater only if that water falling can infiltrate the soil. If we look at this diagram here to help us understand that, if we have a surface that is covered by grass and soil, that's going to allow a lot of the water to infiltrate or to soak into the ground and recharge those aquifers underground. But on the right-hand diagram, we have a surface that's not very permeable, meaning it doesn't allow water to easily trickle through. Far more of that water is going to leave the area as runoff due to the permeability or the ability of the ground to allow the water to soak through it and into the aquifers beneath it. It's really important for groundwater recharge. Runoff, on the other hand, is going to eventually recharge surface waters. It will return water that fell as precipitation to a lake or a river or a pond, and that's an important source for humans to use. One drawback of this is that the runoff gathers pollutants on the way to the surface body of water, and we'll be talking about these issues in a lot more detail when we get to our water unit later in the year. Our practice FRQ for topic 1.7 today will cover the skill of explaining relationships between concepts in a visual model. What I want you to do is to take a look at this diagram of the water cycle. And there are 4 different letters. You have letter A, letter B, letter C, and letter D. I want you to choose one of those letters and identify the process being shown, then describe how water is moving from one reservoir to another reservoir by that process. As always, scan your notes using Cam Scanner and submit them to Canvas to be graded. I am still giving 1 point extra credit on every assignment that is turned in using Cam Scanner.